wasn't neither for you, neither for us, neither for the attendees. Okay, we're going live.
All right.
Hello, everyone. I hope you enjoyed in the data track at the Dev Conference 2022. This is our last session, but it's going to be very interesting. So stay with us and enjoy yourself. Just to mention again that at the end of the session, you have time for Q&A, and you can write your questions in the Q&A chat whenever you have one. Keep in mind also that our Knowledge Partner Pact will be giving away 20 ebooks to the most active conference attendees. So we urge you to participate and be active. Write sessions, leave comments, ask questions, and you can win a great ebook from Partner Pact. Now let me introduce you our speaker for today's session. For this session is Kohsuke Kawaguchi. Kohsuke is
Hello.
a creator of Jenkins and the co-CEO of Launchable. He is a well-respected developer and popular speaker at industry and Jenkins community events. His sensibilities in creating Jenkins and his deep understanding of how to translate its capabilities into usable software have also had a major impact on cloud-based strategy as a company. And before that, he was with Sun Microsystems and Oracle, where he worked on a variety of projects and initiated actually the open source work that led to Jenkins. His topic is very interesting one. We are going to enjoy together. It's named "The State of the Art in Tackling Flaky Tests." You learn how software teams around the world have tackled this problem, from big companies like Google and GitHub to the next door neighbor companies, small ones just like yours, so that you can tackle this in your team and see how this is a part of a bigger emerging movement. So Kohsuke, I'm giving you the stage. It's on you.
All right. Cool. Well, thank you very much for a rather thorough intro. So let me share the
You're
screen
welcome.
and get going here. So, um, well, I guess when I say the flaky tests are a plague that haunts software engineering, let me start with a number that kind of highlights how bad this is. So this one came, I believe, from a Google. Yeah, so it's Google's technical blog or the paper they published, in which they said 1 in 7 tests have some level of flakiness. And I was shocked, these are Google engineers, so supposed to be probably as best as the engineering team can get, and still they get this much flakiness. But while this quantification it might be impactful, that is like not many people might have thought that the 1 in 7 tests have some flakiness, but I'd imagine the general problem of the flakiness probably isn't news to anyone if you spent, I don't know, like a half a year in this industry. Right? And I have my own personal experience to share here at the Jenkins project. And, at one point we built this acceptance test framework, and in order to kind of test the combination of plugins and emulate the user behaviors. It's basically a standard web app testing. And I was really hoping that it did help improve the quality of the Jenkins project, but it turns out that the dishonest is inherently a whole lot more flaky than some of the other testing framework. And in part because of that, it didn't quite get enough traction. It always felt distant from developers. So, I certainly got impacted by the flaky test. I have my own share of experience. So, before we start looking deeper into the flakiness, let's first kind of establish a baseline. So, why is it that the flakiness tests are problematic, right? I think the essence of it, when I think about it, comes down to this: that it creates this crying wolf effect. Tests are supposed to be like a fire alarm. When it catches some problem, it's gonna raise a blaring signal, but otherwise it needs to stay quiet. Right? Because if these fire alarms goes off, but there's no fire, or people evacuate and then they kind of waste their time. You can do it once or twice, but if you keep doing that, then the people start to lose confidence to the system and the process of the whole delivery pipeline. Right? And then if that happens too often, then people start losing the confidence to the people involved in the delivery process, meaning you and I and the other DevOps engineers. So when you, as a DevOps engineer, like if you lose your credibility like that, then that sort of gets in the way of anything else that you might try to do. And then so that's ultimately why I think this, keeping the fire alarm intact is important. Now, speaking of the fire alarm, like at my high school, I went to a boys only junior high school and high school, like a 6 years combined. And it was a rather common occurrence that the fire alarms would go off. And then we just like, we learned to ignore it. And so no student evacuated the building and all that. So um, luckily, like, there was no actual fire, at least throughout the time period I was in. Um, but later, when I came over to the US and I joined the Sun Micro system, and there, every fire alarm, mandatory evacuation of everybody. So I was kind of surprised at that cultural difference, and I sort of later realized that, well, I guess felt lucky rather that the none of the fire alarm that went off in Tokyo in my junior high school was the actual fire. So that's But anyway, I'm here, so it was all good. So that was the fire alarm. The crying wolf effect is from the angle of the DevOps engineers, but also the flaky test obviously hurts the developers, right? The people producing code changes. I mean, I'm sure many of you have done this where you checked in the code, with certain level of confidence that this is a okay change. Like say, let's take a trivial case, like you change the CSS style, or like you updated the documentation, and you need to pass the pre-merge test, and then you wanted to press the merge button to get into the vehicle, the delivery vehicle. But by even before you get back home, you look back at the test results, and lo and behold, some tests have failed because it's flaky, right? And now you have to like rerun the test, go back to home, and feed the kids or something. And at the 10 p.m., you have to open your laptop again, like sign on to VPN again, and then look at the test results on Jenkins, and then then you have to do something about it. Like you have to follow through to get the changes in, or like send in the code review request or whatever. So it kind of wastes everyone's time like that, and also like mentally and like psychologically quite taxing. And at the same time, the flip side of it is also true. That is, when we think of the flaky test, we usually think of it as a problems in the test, right? But sometimes it is a problem in the software itself. Like I think about the rare race conditions that sometimes manifests like in a non-deterministic way, right? So like obviously, if you rerun the test, you can mask those problems, but that doesn't mean the software is bug free. So I had my own share of these problems. There's a complicated race condition in this the pipeline part of Jenkins um, that rarely manifests itself. So we try to nail that down in tests, but it's often very difficult to pin things down like that. So again, like whenever people try to kind of tame the flakiness or see the flakiness and kind of try to ignore those, this is always in the back of some mind of the, let's say, QA folks, the developers, that, well, is this actually one of those, or is this really just a test problem? So, I mentioned earlier, so those are, I guess, why the flaky tests are problematic. Like it's just, it's not great. And then in some sense, you don't need me to tell you that. But now that we kind of know that everyone has this problem, let's start with things that we already know, right? There's a saying that goes something like, if you know the enemy and yourself, then then you need not fear any battle. So there are things we know about the flakiness. That's interesting, right? So before this graph, I think it came from the same report from Google, in which they correlated the memory consumption of a test against the likelihood of fakeness. And then you can see that it draws a very linear correlations. And this, again, the intuitively, this kind of makes sense, right? I think our intuition generally is that the larger test that tests like a whole lot of things together tends to be the one that's flaky. And then those large scale testing also tends to eat up a lot of memory, so that they were able to quantify that. So these quantifications are great because that sort of approaches that lets you approach these problems more methodically. Um, the another interesting things people kind of reported is the typical cause that results in the flakiness. The one that was actually this one I didn't feel myself from my own experience, but the people reported that the time is often a factor in the flakiness. So let's say if the test runs at the end of a month or the beginning of the month or some interesting date, the day of the week combinations, some of the tests tend to break up. But the other one is another common cause, which this happened to me all the time, was some sort of altercation of the global state, or like a test failing to restore some of the side effect, which creates the order reliance, or then so in other words, the tests are interfering with each other, sometimes when run concurrently, and those are also hard to predict. But again, I think you can probably see that how this is a problematic one. Another thing, and this was reported by multiple sources, is that the flakiness are not evenly distributed. So earlier I mentioned that the Google reported fully 1 in 7 tests have some flakiness, but in the same report they only say, well, 1.45% of test runs are flaky. The test runs here meaning like you run a test case, that's a test run, right? So these two numbers at the first glance seems to be at odds, right? Like how can 1 in 7 test flaky? Like is it 1 in 7 or is it like 1.5%? Drastically different number. The GitHub published a different way to look at this, which I think is a little more easier to understand. The idea is that the most of the tests, so I think so in this graph they're tracking how many times a test case exhibited flaky failure in a given time span of I don't know, like a month or something. I don't remember the time span, but as you can see, most of those tests that are flaky have really only failed like once, right? And that number, the test fully, I think like a 24% or so of test cases exhibit one flaky test behavior in a given time span. So those are, that's actually pretty close to 1 in 7. So in this case, it's 1 in 4. But there's like a rather small number of tests. It's like a 0.4% of a test case, which exhibited more than 100%. I mean, more than 100 times of the failure caused by flakiness. So this one test is like a flipping left and right like crazy. So this gives us some hope, right? That is, the idea is like if we can focus on working on these guys, like if we could say remove just one flaky test or fix it, then you can make outsized impact to the overall flaky failures. Obviously, you're probably not going to be able to work on like a fully 25% of the test cases. So the idea, this suggests that we can, if we intelligently focus our effort, then we can make a big dent without, killing ourselves. So those are like some of the things that our industry collectively have figured out about the flakiness. So given that, what have we been doing about this? And it turned out, because it is a universal problem, a lot of engineering teams have tried to tackle this problem from many different angles, and quite a few of them have published these written materials on it. So you can see the who's who. And the thing about these things is like these people spent a lot of effort looking into it, and so they wanted to brag about it. But in my conversation with various testing teams, like I know that they also do more reasonable effort. Like not many people can afford the kind of things like say I don't know Facebook or Spotify are doing. But it's also often useful that what the average software developers are doing. Where is the next step you can take? So I was reading those things combined with my own experience of talking to people. And the way I sort of started to recognize the common pattern is that there's really 3 pillars to how people tackle flakiness. The one is keeping builds green, right? At the end of the day, like that is the purpose of the delivery pipeline, is to take the changes from the left. All the developers are producing change from the left, and we are kind of collapsing them, integrating them all together, and then delivering that to the right-hand side. So keeping that smooth, like keeping changes flowing, that's kind of paramount. Right? So it makes sense that the one of the pillar of the flakiness handling is not to let these flaky failures like get in the way of the smooth flow of changes. But if that's the only thing you do, then flakiness gets masked. So the second pillar now becomes the measuring the flakiness. So and then that leads to the third one. That is the purpose of measuring the flakiness is to raise attention to the right parts of the flakiness. And as we saw in the data in the previous slides, you know, calling attention to the right parts of the flakiness is kind of important. And there's a lot of things that can be done and has been done in that space. And then this hopefully results in developer updating the test, the code, or doing something about it, and then thereby kind of keep the whole thing under control. So let's look at how these different different pillars are being handled. So I'll start with the easy one, so keeping the builds green, right? So by far the most common thing, and I'm sure many of you are already doing this today, is just retries. Okay, if you fail, just accept that the tests are going to fail from flakiness from time to time, and just run it once more just to see if it works. Right. So this one is a Gradle plugin. Every build tool under the sun had some capabilities like that. But interestingly, it does not, the same idea of retry does not stop there. So these are what I call like the smallest retry loop, like the very close to test case. It happens immediately, usually invisible to developers. But there are some larger retry loops. So this one is a Jenkins plugin that involves humans coming in and pressing the button or something to indicate that, okay, like I triaged the previous test failures. These are flaky, so I want to rerun those things and then combine the results and seeing it, right? So, and then some other teams have built more sophisticated retry mechanism. So, the guys who reported at the time is often the cause of the fakeness. Well, they invented a system in which they rerun the test with a different system clock set. So they fake the system clock, right? And then rerun the test. In some other cases, well, this is often, we often like instinctively know that this, if a test is failing for flaky reason, you kind of want to shake things up a little. So instead of running on the same computer, they move to a different VM, different EC2 instance, and you run the same test. So these are often like a much larger retry loop because it takes more time to move the workload off and then rerun things. But they have a these it turned out that these combinations are necessary because if you're simply retrying at the test run level, you're not really changing all that much. So like the global state that was already modified in the program, for example, that's still there. So moving to a different JVM, different EC2 instance, different system time, the more you can shake things up, the expectation is that the flakiness would be, would subside. So that's so people I discovered that combining these things. Now, the downside of flakiness, or the cost of the flakiness, is that if that's all you do, then you end up masking flakiness. And I feel like this is often the number one fear of the DevOps engineers who refuse to kind of take on this sort of automatic retry as a part of the scheme. Right? That is, they are afraid that if well, anyway. So the other side is that it tends to slow down the test cycle, especially one in which there are failures. So it's not unheard of to have some integration test that's measured in the order of minutes, right? Like if you're a Selenium test, clicking around and doing this and that, and the retry count kind of has this tendency of getting pushed up because there's only you only have an incentive to like increase that number, right? Like you see you're a developer, you see this, that this test is flaky, it's failing once more, and then it's under the heat that you are supposed to deliver this. So of course, the easiest thing to do is just like a bump up the retry count and rerun the test. Like, what else can you do, right? If you're in the like a hurry to deliver the fix, you're not going to work on solving the flakiness. It's just not possible. So these numbers just tends to keep going up, and then what that means is when a legitimate failure happens, like in this long running test, then that also needs to get rerun like 5 times, 10 times before the whole thing is declared a failure. So it delays the feedback cycle, which is a problem. So the yeah, so that was the cost of retry. Now the another thing I think that people have done to keeping the builds green is simply to ignore flaky tests or the flaky failures. Dropbox and Google, like they both reported this scheme in which they do not let the failures from, so they mark the tests, they classify the tests, let's say naively, like normal test, suspected flaky test, and flaky test, etc. And then, like if the failure happens in some of those flaky tests that are known to be flaky, they do not use that to kind of block the merge in the pre-merge phase. So they're trying to reduce the heat, like a smooth the delivery process, at least closer to the developers, where developers feel the most frustrations. And these tests, however, still run at the post-merge. And then in those places, like if your development team is set up in such a way that in the middle of the delivery pipeline and onward, it's owned and like looked after by a different team, then they know they have more sophisticated tooling and mechanism to like tame these flaky failures. So that way you can balance out the frustration factor of the developers against not missing the problems or keeping things under control. So that's actually, while again, some people might feel like some DevOps engineers at least might feel like ignoring flaky tests seems like a bad idea, but I often find that that is actually, like if you just eliminate that option from the get-go, then I think you're missing the bigger picture. And that brings me to this interesting psychological barrier. Like every DevOps people I talk to have a pretty fundamental, strong opinions about the flaky, how they should deal with flakiness. The common one being, like we gotta bring developers closer to the fire. Like that is like they should feel the pain that comes out of flakiness, and somehow that provides a motivation for them to work on this. But in practice, like if I speak on the other side, I don't know if that's actually working very well. So that what often how this looks like from the individual developer's perspective is that like I'm trying to run the change, and somebody else's test, who knows who wrote that when, it's getting in the way. So it's like I'm penalizing. I'm like collectively getting penalized, and it's not. And that just like doesn't seem to be fair. And then it doesn't lead me to, change my behavior. So I feel like really, the practical thing to do is to this ignoring flakiness, like letting retries and to some extent masking the flakiness. All of those need to be considered as a practical option here, and then that's my feeling. And it also helps you maintain your credibility to the team, because you don't want to come across as the kind of guy gets in the way of people and their changes in production, right? So I am curious about how do you feel, people in this audience. Looking forward to hearing your thoughts and comments in Q&A and chat. All right, let's keep going here. So that was the first pillar, making the build go smoothly. Now, as I mentioned, like if you are letting these flaky failure go, then often like you need to compensate for that by measuring the flakiness. So what are people doing here? So it turns out that most of the teams, take on this really naive approach, which I call a tribal knowledge, right? Like, if you're a new guy in the team and you see the failure, you have no idea if if that is that cost line might change or not. But if you ask somebody else in the team who's been around for long enough, they kind of know that these tests tend to be flaky, and they can tell you, well, they can kind of sometimes look at the stack trace, and yeah, like I've seen that pattern, it's probably okay. Um, so there's kind of implicit knowledge baked into the team, and that is by far, I think, the common like current state of the art. So so I guess what I'm trying to say is that if that's what your team do, like don't feel ashamed, right? You're just like everybody else. Now, what is a step up from there? So the very common next step, I think, is to try to flag different results that comes against the same code. So the general idea of the test, so their worldview is like, okay, this is a commit that I'm building, and I'm testing that commit, right? So if you see that the same commit being built and tested and produced a different result, well, that sounds like a flakiness. So that's how they measure the flakiness, and it's again a lot of company does this, like Google, and we at Launchable, we look into these people's test data and then like drive the insights. And this is how we calculate this too. And I know from those experience that this does produce, seemingly like a good ordering, like a good flakiness index that like meets people's perception. So it does work. Now the shortcoming is like if you think from like a practitioner perspective, it's kind of somewhat surprising that this naive approach does the trick. So like often I actually expected that. Well, I know that the common pattern is like you run the test and it kind of fails en masse because some external system that the test depended on is down or something. So what often happens, like a QA guy, is it go fix those, and then you run the test. It's the same software. It's tested the same test and by the same test, but now they all pass, right? That happens all the time, right? Like I thought at least. And so these things in this computation, we counted as a flakiness. So but anyway, that's the baseline. And then luckily this is pretty easy to compute. Now, but some of the teams didn't stop there, and I find those interesting. So it's worth talking about. Though again, these are people like much further ahead, and I don't know how practical it is for the rest of us to replicate those. The Spotify guys said, had this interesting approach on their blog. They said, well, the correlation with other failures is a key to tell apart whether the tests are flaky or there's some external system dependencies. So here you have each row represents a different test case, and each column represents a different test sessions. And you see in this like a one test session, a whole bunch of tests have failed together. So they from here so that in their line of thinking, well, this does not look like flakiness. It's like there's a pattern here. Either the code was bad or there's some system down. But these like one-off failures, especially if they're happening against the same committee in the next session, if it's passing, then that's probably a flaky test. So it does, I can see the logic behind this idea of if multiple flaky failures happen together or not, being a clue to figure out the flaky test, to measure the flaky test. And then there's this another one from the Facebook, and I can see that like they must hire the PhD student, and they decide they thrown this new guy at the program, and then came up with this like oversized solution. So they apply what called the Bayesian inference. It's a very clever statistical approach. So the way they kind of treat the world is okay. So if you do a test run, it's like a throwing a dice, right? So there are certain probability over enough time span that this test case fails because because the software it was testing is bad. So this is a good mouse catching a good cat catching a mouse. But sometimes the code is good, so you'd expect that the test is passed, but there's inherent random flakiness in the test case that sometimes lead to a flaky failure, and then that modeling the probability as PF. And then only when the code is good and this like a god of flakiness was happy, you see a passing results. The thing is, from humans' perspective, you can only observe these two together. There's no inherent way to tell them apart. Um, but if you see this is a probabilistic process and you have some actual outcome, observed outcome, you can make some guess about what combination of PB and PF would lead to a behavior like that. So this is so they said, well, if this is observed result, you expect the PF to be to have this kind of distribution. So it's more likely, like let's say 15%. So that's a pretty high flaky number. And the PB, that is that these observed failures likely came from the code being bad, is more like a 5% ish. So more somewhere between 5 and 10, I think, is the center of the body. So that gives them, some mathematical ways to say, well, this is more likely flaky. This is a pretty flaky failures. So that's how you can quantify. I'm kind of curious if this produced a measurably better results on more naive algorithm. The thing about these things is complicated solution doesn't always produce a good one, but at least you can see the line of thinking. And as far as the statistics goes, actually Bayesian inference is not that complicated. So this is so a lot of people have looked into this problem. All right, so further moving on to the third pillar, which is escalating flakiness. So now that you measure the flakiness, all right, your goal shifts to then raising the awareness to the developers. The naive solutions that people take on is like create a ticket to investigate, or just mark the test that's skipped, or even just removing it. I kind of find that the people seems to be rather hesitant to remove the flaky tests, which I find it odd. Maybe it's just a psychological thing. Like I used to, hate to remove code in general, but somewhere along the line, I feel like their perceptions of our community has changed. That now people feel actually good to remove the code, right? It's like every line of code we need to maintain has certain cost, psychologically and literally. So if something is not if a line of code is not producing enough value, then it's better to remove it. Instead of dragging on everything along. I think the same thing can be said to testing as well. If the test is not producing good enough value, then sometimes it is better to remove it. But when it comes to flaky test, I don't know. Maybe it's the sense of defeat. So people are not taking on this naive solution as much as I think they should. Now, some of the people went all in on this, as far as I can tell. So this one, as you can see, it came from the GitHub. They apparently built a whole freaking web app in the system that kind of gives them like the scoring of the flakiness. So this is showing you one flakiness. And here you can see they came up with impact scores. So that's an attempt to quantify how bad this problem is. It says, this one flaky behavior, they impacted 2,700 builds, and it impacted 142 developers, blah, blah, blah. There's just a lot of information, in part in trying to raise awareness to the right one, but also part trying to anchor this not to the whole team and then dilute the responsibility, but rather try to identify the starting point. Mona Lisa was the last person modified this test file before it became a whole lot flaky. So maybe she's the one that should start looking into it, right? So some of this detective work, the early entry-level detective work, is taken on. And again, a lot of companies talk about systems like that. So within the hope, as I mentioned, since the focusing on the right flakiness is important, I'm kind of curious to hear how successful these things are, given given the apparent effort it must have taken to build something like this. Now, another one that was really interesting for me was from Dropbox. So their engineering blog was, this part of their system is more focused on machine brain doing things automatically. So so what happened is when they see a test fail in one of the CI runs, so it gets, that test gets classified as noisy, um, which means like it's not the, there's suspected flakiness. It could be a legitimate code test problems, but it could be it also could be flaky. And once a test is flagged into this state, then a bunch of automated process, they said, will happen. Like, for example, just simply rerun the same test over and over just to establish some baseline. Sometimes they go back to the previous build and then rerun those tests over and over. Presumably they pass, but if it's a flaky, those successful tests started fading after several runs. Well, that's also a sign that it was a flaky test, right? So the beauty is like the system takes care of that without human involvement, and then that determines whether the test is judged flaky. Then the test is morphed into quarantine state, and then they are no longer be used as a part of pre-merge. And the tests in this category presumably are getting looked at by humans. Or if the test is broken, meaning it's consistently failing, then the change gets like picked out. So that's more, I guess that's what we normally think about the test failure. But it's they use if imagine it's like a high volume system. There's Dropbox huge engineering team, right? So they can pick apart the problem. They are not testing every commit. So when the failure happens, they employ on things like bisecting and reruns and so on to pin down the problem and throw it out after the fact. So that's more, the whole system I can see is designed for more high throughput situation, which I think is actually useful for other teams as well. So that's these are probably one of the most sophisticated ones that I've seen. So, but when I was throughout this, like looking at this, I'm really curious. At the end of the day, all this was supposed to be to raise awareness, the right part of the flakiness to developers. And so, is that driving? Is that happening? And more importantly, is that changing how people react to those? Because if they are basically what often happens in this system, I'd imagine, is just tests get put into quarantine state, which is practically the same as getting removed, right? Like you're just not not deleting the code from the Git repository, but if it's not getting run, then it's as if it doesn't exist. So I wonder if all of that is just a show, the facade to kind of do soft deletion. Then if that's the case, then you don't really need to build the system like that. You just need to delete the test, like I said. So if all of that work is just to kind of the tame or psychological mental barrier, then that seems like a little waste. A little feel like a wasted effort. But anyway, so the last bit is the last bit is something that didn't fit into these three categories, but I love this. Felt like the best example of the engineering approach, which is more architecturally addressing this problem in such a way that the flakiness is far less likely. So Airbnb has this long series of blog posts in which they said, they're testing their mobile app, and the mobile app had to be tested from basically Appium and the user level simulation. So those are often, inherently flaky, timing related issues, the data communication with the network, the mocking of the server. It's all quite painful. So what they came up is okay, they decided that we need to build the right the mobile framework that is far more amenable for testing. So it's kind of like how React decided that you shouldn't be writing code like in jQuery days or whatever. So I'm gonna spare you the details of how exactly you go about it. But this is the only kind of thing. This is the kind of thing it can only happen rather when you kind of same people start thinking about the engineering and the QA together. Right? So when people talk about the DevOps, well, this is the kind of outcome we are trying to drive. So it was great to see that in some places that has borne fruits. Where it's closer to me in the server side in Java application development, the whole idea of inversion of control in part was driven by the testability of the things. So those there are examples of this in the industry. I hope to see more of those. Now, as I was looking at these like a different approaches, what became clear is that there's like a two pieces of this puzzle in tackling flakiness. And the and that kind of gave me some thought about how this should unfold going forward. And the one is, like basically so there's all of these sophisticated mathematical analysis and like trying to drive the awareness and visibility. All of that comes from ability to run the arbitrary tests against the arbitrary past builds, being subject under a test, and being able to do so rapidly. And so this capability, for example, and then whereas historically, right, often like a build process treats the build and tested one and only and together, and it's often difficult to just pull apart the portion that runs the test and be able to pick up the build that was created a week ago and run this selected 5 tests against it in the rapid manner, or be able to do so in a massively parallel scale. So this, to be able to do this kind of things, where you need a build process that's capable of doing that, you need to design a delivery pipeline in which you can do these things, like say deploy the staging environment and run these tests. And then you need the fungible, distributed test runner. It kind of points to this like a Docker container thing, given this kind of world. That capability needs to exist. And this part is really inherently dependent on the kind of software you're developing. So I see no way around that than individual teams building it. However, once you have the data that comes out of those and crunching those numbers that Bayesian inference, they remember the Facebook guys came up with, I feel like there's no point in that part. Seems like a massively reusable across different software engineering teams. So I'm expecting that to become more available commodity solutions, either the service or the open source software or something like that. So this is where I feel like, okay, I mean, that's part of what I'm doing, interested in is we could build this brain, and if that has a means to like talk to this ability to build and test on your side, and combination of that could help us move the industry forward. Because after all, like basically all of our progress comes from reusing somebody else's results. Like, so we need to find the right way to reuse somebody else's work, in this case the brain that somebody has built that can be plugged into your tentacles inside your build system. So anyway, I need to, I'm trying to leave some time for Q&A. So while we are taking these questions, in this slide, I put a lot of links to the actual engineering blogs and post about it. If you wanted to get a copy, happy to provide you. Just drop me an email at this following email address. And yeah, you can read up on all these blog posts yourself. All right.
Thank you, Kaski, for the great talk. It was very interesting, very informative. I have any questions. I urge the attendees to ask whatever they want in the Q&A section.
So maybe I can ask a question. Like I said, yeah, I'm curious how you guys are handling flaky tests. Right? Like, have you been doing anything that's not covered in here? I'm very interested in hearing that. So.
Yes, somebody should express their opinions on that.
Yeah. All right. If not,
So how
I
long
hope I
have
didn't put
you
everyone to
been
sleep.
how long have you been working on that flaky test situation?
Well, I mean, this is not the. I mean, there are lots of. I guess it's not that I'm working 100% on flakiness, but this has
Yeah.
always been on my radar. So, like I mentioned, for me, personally, this problem was at the Jenkins project. So, in some sense, it's been with me for what, 10 years easily. Yeah.
Mm-hmm.
Yeah. So, but I was lucky before that. I was working on a compiler, and then I didn't know back then, but the compiler is like one of the most deterministic systems. You put the same input, you get the exact same output. So the testing it was rather easy. But since then, I have never been that lucky.
So, in your opinion, the things are getting better with the flaky tests?
Well, so I think, yeah, things are getting better in the sense that these sophisticated approaches, the emerging of that, it's a relatively recent occurrence, but the things are also not getting all that better for the average software development team, because not like really none of these things, most of these things, aside from lead runs, is reusable. Yeah, okay, great. It's great that the GitHub guys build this system, but like the rest of us can't access it. So that's why I kind of I put this build versus buy side. Buy in the sense of like a reuse at the end of it, because for us to kind of shore up the state of the art across the industry, we need to figure out what are the things that we can reuse across the different teams, and then find a way to reuse it, and then like create the interface between that and then what we individually need to do.
Okay.
Anyway, so
Thank you very much. Thank you very much for your answers. Thank you very much for your session. Hope to have you again here with us.
yeah, looking forward to be there in person
Yeah,
soon.
next time in
Yeah.
person. Thanks to all attendees for having stayed with us and having watched all the topics and all the talks in the data track on the conference. Please stay with us on the with the closing keynote speech. It's going to be very interesting at 4:30, and hope with us. Thank you very much and have a good one. Bye-bye.
Bye.
Bye.